Hi everyone, this is a video to demonstrate the Arraylist class from the Java programming language. An arraylist is a collection of items that are stored internally as an array, but the size of this array can grow and shrink as the number of items in the array change. The declaration of an arraylist is arraylist parameterized by what type of items it contains. Now, an arraylist cannot contain items of primitive data type. It must be objects of some class. So if you want to create an arraylist to contain integers, it has to be integer with a capital I. Name of the list. That's your declaration. And you can instantiate it as list is a new array list of integers, of course. I get an error because Java requires you to import ArrayList from java.util, which we can do like that. Once that's done, the ArrayList class has a lot of functionalities like adding an integer, adding at a specific index an integer, adding all the items of a collection, check if the list contains a specific object, check if the list contains all items from a given collection, get is a very important method to get the value of an item at a given index. The method is get. Index of, you can check the index of a specific item. Is empty again is very important. Index of, last index of. Remove, you can remove an item from a specific index. You can also remove a specific item, of course. When you remove an item at a specific index, it actually returns the object that was removed as well. So you can see which item was removed. Size, which gives you the number of items in the array list. Set is very important. So you can overwrite the value at a given index by a specific item. You can convert an array list to an array, which returns an integer array. ToString simply gives you the string representation, and those are the important methods. So just to explain how this works, I'll add a few items. I'll add 4 items, 10, 50, 20, and 40, and display my list. When I run this program, you can see that the 4 items in the order they were added are 10, 50, 20, and 40. You can also add at a specific index an item 70. So here I'm saying add at index 2 the item 70. So 70 will be added here, and thereby 20 and 40 will be pushed forwards. So the array list will become 10, 50, 70, 20, 40. Please note that in all of this, you don't have to worry about the size of the internal array. That all happens behind the scenes using dynamic array creation. You can determine if the list contains a specified item. So if you check the index of, let's say, item 20 and display this location, so the item 20 is at index 3 there, 0, 1, 2, and 3. You can remove an item at a specific index, and let's say I remove the item at index 1. you can now say list after removing this item at index 1, which was your item, list is followed by the list contents. So here when I run this, I'm trying to remove the item at index 1, which is 50. So the output I get is, after removing the item at index 1, which was 50, the list is 10, 70, 20, and 40. You can change the contents of a specific item. So let's display the list one more time. So after removing the item 50, the list is 10, 70, 20, 40. If I want to replace 70 by 60, I can say list.set at index 1, where item 70 is, replace it by 60. So my list becomes 10, 60, 20, 40. Of course, sometimes you might want to actually replace the item 70 by item 60. So you don't want to manually go and see that the item is at index 1. So what you can of course do is, you can say location of my item that I want to replace is list.index of the item 70. So if the purpose is to remove or replace the item 70 by 60, first you find its location and then you assign the value 60 to that location. And this also does the same thing. Let's write a bit more useful program. So I'll generate a random number generator for this. And let's say I add 5 items to my list. One more thing I would like to do is to actually create a new program for this. So we create Arraylist demo 2. Right. We create our array list of integers, call it list. I combine instantiation with declaration itself. Import Arraylist and the random class. I'll add 10 items to the array list, 10 random items. List.add r.nextInt up to 6 plus 1. So each of the 10 items that I'm adding to the list are between 1 and 6. When we display a list, it gives you those 10 items. So these 10 items are added to the list, and I can perform some operations on this. So let's say I'd like to see how many, what's the frequency distribution. My contenders are 1 to 6, correct? I can create a method, count occurrences of the item I in the array list. So for this, I'm going to create a method. So this is my target and that is my list that I'm passing to this method. I can check, first thing I have to check is if the list is empty, return 0. Otherwise, count how many times target is present in the list, which you do using 0 to size. Now please note that unlike an array where the number of items is given by array.length, in an array list the number of items is given by list.size. If the item at index I is in fact equal to target, then you found another occurrence and result increases. When you've checked all the items, we return this result from the method. So in our client we can say I occurs C times. We run this and you can see that these numbers 1 through 6 occur these many times. You can increase the sample size to a bigger value like 10,000. So here, this array list in fact contains 10,000 items. It's a really large value. And you can see that the frequency distribution becomes very, very uniform. In fact, the bigger array list we create, of course it will take a little time. This frequency distribution is very, very uniform for large sample sizes. Let's go back to 1000 for a quick run. So there you go. You got 1, 2, 3, 4, 5, 6. Using this kind of functionality, so we can say over here that this is a method that displays frequency distribution. So we click on refactor, extract method, display frequency distribution. Cool. We can also say int most frequent is get most frequent value from the list. Now that's gonna be based largely on the frequency distribution. Anyways, I'll create a method first. I check the frequency distribution of each of the 6 values. Max count is 0 and max value or most frequent value is 0 as well. We can see if C is more than the max count becomes C and most frequent value becomes I, which is the value for which we executed the loop. Once the loop is finished, we return the most frequent value. Display that value in the client, and you can see over here that 1 occurs 156 times, 2 occurs 140, 3 186, 4 152, 5 196, and 6 170. And the most frequent value was 5. Again run this. Most frequent value is 2, which occurs 180 times. You can determine the average value, which is the average of all the items in the list. So we create a method average. Now here I'm going to introduce a new kind of loop that we haven't seen before. As I said earlier, one thing that you can do is total is 0. You can go through each item by going I equals 0, I less than list.size I plus plus, and total increases by list.getI. But do you really need the index? Not really. All you need to do is visit each item. Now Java provides a really nice way of doing that. Since it's an array list of integers, I can say for an integer item belonging to the list. So this is a loop that goes through every item in the list, and inside the loop I add the current item to the total. So if my array list is hypothetically, let's say 626631, that's all. So let's make it a bit smaller. Let's say it has 10 items. Of course I have to return total multiplied by 1.0 divided by list.size. So let's run this. Okay, so let's say my list is 461266256. What this loop is doing is it iterates through my list and calls the current item. That's all it does. So when the loop starts, item is 4. Total increases by that item 4. And as soon as that item is accessed and when the loop header executes again, that item automatically pushes forward. So the item is now 6, then next iteration item is 1, then next iteration item is 2, then 6, then 6, then 2, then 5, then 6, and 6. So this is a very useful way when you don't need to know the index of the value. Of course, if you need to know what the index of your particular item is, then you need to traverse the loop in the more classical way, which is for int I equals 0, I less than list.size, I plus plus. So take a look here in count occurrences. Do I need the index? Is the index useful for my purpose? Not really. So I can just say for integer item belonging to the list, if the current item equals target, result plus plus. On the other hand, let's say I have a method public static int get or what method can we write? Public static boolean is ascending Arraylist of integers list. In this example, of course, the first thing I do is if the list is null, return false immediately. Otherwise, I go from the first item to the second last item, not the last item, the second last item. Inside that, if the current item is more than the next item, it violates the ascending order principle, so you can immediately return false. If the loop finishes without any violation, then you return true. So if you take a look at this example, I cannot convert this loop into an iterator loop because the index is important to me because I'm accessing the current item with that index and the next item with index I plus 1. So here I run this and I display average is average if the list is in ascending order, you display in ascending order, otherwise display not in. So when I run this, you can see that the list is not in ascending order clearly. Of course, to create a list of 10 items such that the items are between 1 and 6, the probability is very low. So let's just create a list of 4 items: 2, 3, 1, 3, 6, 5, 6, 3, 5, 3, 6, 5. And here you can see 1, 2, 4, and 6. The list is in fact in ascending order. So this is an example of a program that uses Arraylist and the most common functionalities that it provides. Hope you enjoyed that. Thank you very much.